So I'm going to try to talk about three things. First of all, who I am and what I do, although Allison already introduced it. A little bit about why I say climate change is everything and some of the opportunities for responding to it. I'm going to be whipping through this presentation much more quickly than the material usually requires in order to leave lots of time for questions. So just so you know, this is a pretty bare bones skip through the climate science. So who I am and what do I do? As Allison indicated, I am a legislative officer. That means I'm not from the government. I'm a watchdog over the government for the legislature and through them to the people of Ontario. I'm required to be nonpartisan, impartial, and independent. And in addition to my job as guardian of the Environmental Bill of Rights, I'm required by law to report to the Ontario legislature once each year on three quiet little topics: energy, environment, and climate. And I'm talking today about my most recent climate report and why I'm spending so much time going around Ontario telling people you are not worried enough about climate change. I thought I knew quite a bit about climate change when I was in private practice. As I think Allison mentioned, I was an environmental and energy lawyer for 40 years. But I was really blown away by how much worse climate change is than I thought when I became commissioner. And that's what I'm trying to tell you today. We do these reports at public expense. We think they're really good. We hope that you will take a look at them. You'll find them on our website, eco.on.ca. If you forget that, you can just search Environmental Commissioner of Ontario. You'll find us. One of the tools we have that you might use is this one. Under the Environmental Bill of Rights, the provincial government is required by law to tell the public when they are proposing an environmentally significant decision. And they do this through a piece of software called the Environmental Registry. And the Environmental Registry software at the moment is really pretty awful. It is going to get better, quite a bit better next year, but at the moment it's still pretty bad. And one of the consequences of that is that if you were interested in keeping up to date on, for example, Blanding's turtles, there's no way for you to find out whether the government's doing anything with Blanding's turtles unless you go onto the registry every day and search, which some organizations do. But for most everybody else, the better thing is to use our alert function and put in your email address and the keyword that you want, and you will get an email to your email box for free every time the government posts a notice that has that keyword. And we've sent out more than 500,000 of these free notices in the last year or so, so I'd encourage you to make use of that tool. And tomorrow we're going to be releasing our major environmental rights, environmental protection report. If you're interested, I am going to be doing a press conference at Queen's Park, which we will post, and we'll also be doing a webinar in November on that report. But today I'm here to talk about climate change. And if you don't remember anything else about what I have to say about climate change, it's kind of summarized on this slide. Now, I ask everyone to start by thinking of some young person that you care about, although I suppose if you're a young person, you could pick yourself. These two are very important to me, but everyone needs to know who they're working for on this issue. Because although climate change is here now, and it is already having significant effects and will have much more significant effects during my lifetime, it has a much bigger impact on the future options of these two and other young people. So I ask everyone to remember who you're working for and why. One of the advantages of talking about climate change in Canada is that most people know the basics. Most people know that virtually all climate scientists in the world agree that climate change is caused by us. It's serious. It's from greenhouse gases. It's here now. What people don't always know well is the mechanism. How is this actually happening? So I'll give you an example. Imagine a bathtub, and this bathtub is pretty full of water. The tap is running, putting more water in the bathtub, but there's also, the drain is also a crack open. So as long as the water is draining out of the bathtub about the same rate that the water comes into the bathtub, the level of water in the bathtub is going to stay about the same. Well, that's a little bit the way things are in the atmosphere. The sun's heat comes every day. It waxes and wanes a bit with the seasons and with solar cycles, but by and large, the sun keeps shining. And until recently, most of that heat, almost all of that heat, escaped again when it was reflected back into outer space. What greenhouse gases do is they're like hairs in the drain. One or two hairs don't change very much, but the more hairs you have in the drain, the harder it is for the water to escape. And if the water keeps coming in at the same speed, eventually you've got an overflow. But it's the same thing with climate change. The more greenhouse gases we put in the atmosphere, the harder it is for the sun's heat to escape again. And if it can't escape, it builds up. Now, greenhouse gases are increasing. The most common greenhouse gas that is primarily from human activity is carbon dioxide. And as you can see on this chart, in 1992, when the entire world agreed to the Framework Convention on Climate Change, we had basically about 20 to 23 gigatons of carbon dioxide that we emitted into the air and water and land of the world every year. And now it's over 36. So in the 25 years that we have known that climate change was an urgent human, environmental, and economic problem, what we've done is made things a lot worse. And in fact, every year we've emitted more and more and more CO2 until the last couple of years, where at least the rate of increase has leveled out, mostly due to China reducing its coal consumption. But we still are at the highest level of CO2 emissions into the atmosphere that we know of ever in the history of the world. So where does it go? About a quarter of it goes into the oceans, acidifying the oceans. About a third of it goes into soil and vegetation, which is not a stable place for it to be. And the rest of it goes into the atmosphere. So what happens in the atmosphere? Well, you can see from this chart that the level of CO2 in the atmosphere has been going up and up and up more and more steeply. It's going up 2.5 times as steeply this decade as it did in the 1990s, which isn't that long ago. Now, people always ask me, well, isn't this just a natural cycle? And it's absolutely true that there are lots of natural cycles. And all those natural cycles are continuing. As I mentioned earlier, there are the seasons, there's the 11-year solar cycle, there are wobbles in the orbit of the Earth around the sun, there are volcanoes, there are ice ages, and in the last several million years, we've had all of those. But through all the natural variation, carbon dioxide in the atmosphere always stayed between about 180 and 280 parts per million. But we blew past that in 1860 when use of fossil fuels really began to spread. Now you'll see on this chart that 350 is in red. That's because it's the closest thing to a magic number that we have. That magic number is the best estimate we have is the highest level of CO2 that you can have in the atmosphere for long and still have the kind of world that existed when I was young, with coral reefs and mountain glaciers and low-lying island states and fairly predictable climate. And we blew past that in 1988. Now the key is it takes about a generation for us to start to feel the impact of the CO2 we've put in the atmosphere. And so here we are almost exactly a generation after 1988. And what we're seeing all around the world is the collapse of coral reefs and mountain glaciers and the erosion of low-lying island states and more unpredictable weather, all the things the climate scientists told us to expect if we allowed CO2 in the atmosphere to continue to build up. Now it looks like we're permanently over 400. I mean, permanently for human purposes. My lifetime, my kids' lifetime, my grandchildren's lifetime, maybe more than that. We hit 410 for the first time this year. There is an annual cycle, as you can see from the chart, but so when was the last time that humans experienced 410 parts per million of carbon dioxide in the atmosphere? And the answer is never. The last time CO2 was this high in the atmosphere, there weren't any humans. So no one can tell us for certain what it's going to be like to live in a world where CO2 in the atmosphere is permanently over 400, because no one's ever lived in that world. But we do know that it's going to take about a generation for us to start to experience the impacts of what we have done already. And we know that the carbon dioxide is going to stay in the atmosphere a long time, trapping extra heat. About a fifth to a quarter of the carbon dioxide that we are emitting today will probably still be in the atmosphere, trapping extra heat 1,000 years from now. Now, it's not just CO2, though. As you can see from this chart, the CO2 is the turquoise. So about 2/3 of the extra heat that's being trapped is from the CO2. But there's lots of others. So methane is the light green. That's primarily from fossil fuels, also from animal agriculture. The next largest one is that magenta color, that's nitrous oxide. It's primarily from the use of chemical fertilizer on agricultural land and also from chemical plants. And all the rest is refrigerants. Refrigerants are almost uniquely bad for the climate. Individual refrigerants can be hundreds or thousands of tens of thousands of times worse than carbon dioxide in terms of trapping heat. And because they are purely artificial chemicals made by humans, there's no natural processes to take them back out of the atmosphere. So they may stay there for thousands or tens of thousands of years. And you put all that together, and this is last year, we had the highest temperatures in human history. And the dark red is places where we blew away temperature records. And as you can see, we blew away temperature records all around the world. We blew away records for how many records we blew them away. And about the only places in the world that were cooler than average were the places where we're melting the ice caps. And you get a lid of cold water on the ocean. What all of this is doing is changing the way wind and water and heat moves around the world. And that changes the winds and the currents on which our weather depends. Now, where is all that extra heat going? I talked a few minutes ago about where the extra carbon dioxide is going, but where is the extra heat going? So what you'll see on the left is a summary chart of what's happened in my lifetime, because all of this has happened in my lifetime. How much extra heat has been trapped and where has it gone? Now you can see at the bottom of the chart, there is a teeny red line. And that teeny red line is the extra heat that's in the atmosphere. So everything that we are experiencing as we walk around, the 17 degrees above zero that it was in February, the extraordinary warmth we had this weekend, all of that is from the 1% that's in the air. The rest of it we don't tend to notice. There's about 3% roughly in soil and vegetation. There's roughly 3% or so be melting ice around the world. And all the rest of it has gone into water, primarily into the ocean. Now, the consequences of that are, there's some basic consequences that are really straightforward. The first is warmer water holds less oxygen. So that's bad for anything that lives in the ocean and needs to get its oxygen from the water. But warmer water also takes up more space. So warmer water takes up more space. That means the sea level has to be higher. Warmer water also evaporates more quickly, so you get more water into the atmosphere. And you put together warmer oceans and more water in the atmosphere, and you get fiercer storms. Now, I mentioned a few minutes ago that only 1% of the heat is in the air. Sometimes you hear people saying global warming as if it were the same as climate change. I don't use the phrase global warming because people who hear it sometimes think that it means that everything is always going to be warmer all the time. And that's just not how the world's climate works. All the same natural cycles are still happening. So what you're seeing on this chart is the average temperature of the entire world. There's a lot of room to average things out when you're averaging the temperature of the entire world. And even so, As you can see, this is a really jagged chart. It doesn't look like the CO2 chart at all. Sometimes the whole world's average temperature goes down for a year or multiple years, sometimes almost a decade. But the overall trend is still going up. And it has to, because we're trapping so much more heat in the world. Now, this is one of the most important charts, because the natural tendency of most people when they get really bad news, and I know that what I'm telling you is really bad news, the natural tendency of most people is want to wait for normal to come back. And that certainly is the natural tendency of most bureaucracies. But normal cannot come back. So I'm from an evidence-based profession. As you know, I'm a lawyer. Most evidence-based professions, engineering, infrastructure standards, crop design, law, actuaries, underwriting, most of that is based roughly on the average of the 20th century. And the zero line that you can see on this chart, that's the average of the 20th century. We don't live there anymore, and it cannot come back, because we've already pushed the level of CO2 in the atmosphere over 400, and it'll take a generation before that really starts to kick in. Now, another problem with the idea that global warming means that everything's warmer all the time, that concept misses, is that the extra heat isn't evenly distributed. It's not evenly distributed in time, it's not evenly distributed around the world. And one of the key things is this question, well, if you look at the drawing on the right, if your head is in the oven and you have third-degree burns, and your feet are in the oven and you have feet are in the freezer and you have frostbite, on average, how are you? Well, the statistician would say that on average you're fine. But in fact, it's the extremes that do the damage. And what climate change brings us is more damaging and more unpleasant extremes. The picture that you see on the left is a street in India melting in the sun a year ago. And in fact, extreme events have already tripled even here. So we in Canada and the United States, we're basically the luckiest people in the world for many, many reasons, including climate change. Things are much worse in many other parts of the world, but even here, extreme events have already tripled. And if you remember that young person that you care about, what I always ask my audiences is, would you like that young person to be in a car driven by someone who had been drinking? And hopefully they say no. And I say, well, why? Why don't you want your young person in a car with someone who's been drinking? And the answer is because there's more likely to be a crash. And in fact, someone at the legal limit is roughly 3 to 4 times more likely to have a car crash than someone who hasn't been drinking. It doesn't mean that non-drinkers never have car crashes. Lots of car crashes happen without alcohol. But they're 3 to 4 times more likely if the person's been drinking. Well, that's the situation we're in with climate change. There were always extreme events. There will continue to be extreme events, but now they have already tripled. And that's before we start experiencing the impacts of what we've emitted in the last generation. So in essence, we've taken our children into that car with triple the risk, and they can't get out. So it means when, not if, for a whole range of impacts. In Ontario, milder winters on average, not every year, which the northern communities that depend on ice roads, they're becoming much less reliable. Winter sports will be less reliable, snow cover will be less reliable. That has impacts for forestry and for agriculture and for gardens. We can expect a lot of wetter springs, faster melts, that means storms, floods, and droughts. And then hotter, drier summers, more forest fire, more invasive species, a lot of things that are going to be really challenging to deal with. Now, some of these show up. A lot of this is already showing up in catastrophic insured losses in Canada. Again, this is just Canada, luckiest people in the world. And this is constant dollars, so you're not seeing any inflation in these figures. And this is just insured losses, and by on average, half of all losses in Canada are not insured. And you can see what's happening to the trend for insurance losses. In the United States this year, with the wildfires and the hurricanes, I'm sure their chart will look eye-popping, but I don't have it yet. So how much worse are things going to be? Everything I've shown you up until now is data, not computer models. But to look into the future, all we've got is models. This is a model that was done at the York University for Southern Ontario. And this was their best case based on the assessment report number 5 from the Intergovernmental Panel on Climate Change. That model, the AR5 model, is too optimistic, as I think we'll see next year. But in any event, based on that, that's what they're looking at for Southern Ontario. So if the whole world did everything right, we might avoid more than 2 degrees average change. But gee, an awful lot of things have happened since 2010 that, or 2005 rather, that where not everything was done right. And if it's not done right, well, we could this century be over 6 degrees above what we consider normal. And no one can tell us what that would mean other than just enormous disruptive changes. This is a model from Environment Canada of basically if they were fairly optimistic, if they're actually quite optimistic about the whole world getting smart and reducing coal and improving energy efficiency. So what kind of changes are we likely to see this century in temperatures in Canada? And as you can see, we're in for a lot of change, with the biggest changes, as always, for the far north. So now you're looking at maybe 2070, 2075, 2080. That's a lot of change. Now, everything I've talked to you about so far is about the impacts of what we humans are doing. And if we had got smart in 1992 when we the whole world signed the Framework Convention, that might have been enough. But because we continued to increase our emissions instead of decrease them for another 25 years, we have unleashed other changes in the natural world that even if we started doing everything right, we can't stop. And one of the questions that I always ask people is, what would a tipping point look like? How would we know if climate change had gone from being a really big, important thing that was going to happen to other people in other places later to something that is already here and the biggest emergency any of us have? What would it look like? And I think it might look like this. So what you're looking at here is a summary of all the global sea ice measurements ever taken. Now, this is not sea ice mass or volume. This isn't how much ice is there. This is how much of the sea is covered with ice. And that's particularly important because of the feedback loop. The more ice you have, the more of the sun's heat is reflected back into space, because ice reflects heat. But the more ice you melt, the more heat you absorb, because then the sun shines on dark water. And as you can see, the amount of sea ice decreased decade over decade since satellites began, but the pattern never broke. And you see that dark red line, it didn't break until September 2016, just over a year ago, and that's when it fell out of bed, with catastrophic loss of sea ice in both the Arctic and Antarctic. So the world is starting to change in ways that we will not be able to control. So people ask me, of course, well, so is it too late? And I have to say, too late for what? Is it too late for that young person that you love to have the same opportunities, the same world that I had growing up? Yes, it's too late for that. Is it too late for Canada and other countries to avoid major challenging changes? Yes, it's too late for that. Is it too late to make a difference in what's coming? No, we're in that moment right now. And Ontario is doing some important things. In fact, Ontario is doing a lot right. Closing the coal plants, enormously important, not just for climate change. I don't know if you know anybody with asthma, but in 2005, Ontario had 53 smog days. And those days, my husband had asthma, and those days were brutal for him. 2015 was the first year in Ontario when we closed had closed all our coal plants. And how many smog days did we have? 0. It wasn't just Ontario, the US also closing coal plants, but hugely important. We have the cap and trade system to put a price on carbon, which began January 1st. We have a climate change action plan, and we keep being told we're going to see something soon, a strategy for climate adaptation. So lots going on. Still a huge amount to go. Ontario committed to reducing its GHGs, its greenhouse gas emissions, by 6% below 1990 levels by 2014, and we made it by the skin of our teeth. And primarily, as you can see, by reducing electrical emissions from the electricity sector, and also industry, the red dot, they reduced their emissions quite a bit. But everybody else got worse, and particularly transportation. And that's all of us. That's not industry. That's primarily all of us. So in a way, closing the coal plants was the easy part. Reducing our emissions from here is going to take everybody to make big changes. Fundamentally, we've reached the point where we can no longer have both of the two things we really, really want. An energy system that we're used to and makes our lives convenient and prosperous, and the climate system on which our lives depend. We can't have them both anymore. In fact, they're both changing. So this is a brief description of how cap and trade works. Basically, there's a limit on the number of allowances that the province emits. Anyone who uses fossil fuels needs allowances. There are 31 megatons on the right. Those are emissions, greenhouse gas emissions that don't come from the use of fossil fuels. That's methane and nitrous oxide from mostly agriculture, waste, and forestry. There's about 40 megatons of emissions from industry. They need their own allowances, and all the others come from liquid fuels and natural gas that we all use, and the distributors have to get those allowances, and this shows who pays them, who don't, and I'll be glad to explain this if anyone has a question. Meanwhile, there is a lot of other things going on internationally. Despite Mr. Trump, there is a lot of encouraging international progress. The Paris Agreement, tremendously important. The whole world, every country of the world is in the Paris Agreement except Syria, and the United States now says they're pulling out. But, or at least Mr. Trump says that he's going to pull the US out, but lots of other Americans are saying, you know what, we're still in. Mayors, state governors, business, finance are saying, you know, we're going to make the US meet its Paris commitment with or without Mr. Trump. We've got the Kigali Amendment to the Montreal Protocol. I mentioned earlier how enormously important refrigerants are as greenhouse gases, and so there is an international treaty on reducing refrigerants, tremendously important. There's a pan-Canadian framework for putting a price on carbon, and even international aviation is going to start paying something starting in 2020. And there are lots of opportunities at home for making things better. One of the fun ones is, okay, did you know, for example, that you can run a bus on poop? Now, there are no people actually using toilets on this bus. That's not how it works. But there's a lot of energy in human sewage. And we have a tremendous amount of that energy in Ontario simply goes to waste. But there is one municipality, and that's Hamilton, that is capturing biogas from human sewage and using it to run their buses. But we're Canadian, we're too polite. They don't paint it on the bus, so I'm using the British picture where they do. The bottom line is there are enormous challenges ahead. But it's also true that the very same things that will help us reduce our greenhouse gas emissions will also help us create so many other things that we want: energy independence, preserving the rainforests, green jobs, livable cities, cleaner water, healthier children. All of the same things that will reduce fossil fuel use will help us with those things. So whether you believe in climate change or not, we should be doing the same things. Now, when it comes down to it, no one can do everything, but everyone can do something. And everyone that I know wants hope on climate change. And I think that there's only one way to get it. We have to start with knowledge. We have to look the facts in the face, which is what I'm hoping I'm helping you do today. But we can't stop there. Then we have to take action. We have to take action together. And that's what gives us hope. So what can you do as an individual, as a family, as a school, as a community, as an organization? Well, there's three really big things. The first is figure out your carbon footprint. and reduce at 5% every year. Project Neutral has got a good online calculator to help you figure it out. But also tell people. Tell people what you're doing, track your progress, make it public. You're more likely to do it and you're more likely to inspire others. The second thing is get ready to adapt. There are big changes coming. And we all have to be prepared for them. And the third thing, and particularly important in an election year, is to speak up. If everyone who cares about climate change goes and speaks to their political representative and asks them, what are you doing about it? What else could you do? What's getting in your way? What kind of help would you need? That could have an enormous effect on what happens in the next election. Government, politicians at all levels, they are exquisitely sensitive to what they hear from their constituents. They don't want to get too far ahead. They need to know that they have support. It's the most important thing you can do. So thank you very much. Any questions?
All right. Thank you so much, Commissioner Saxe. So the message boards are open, but I was going to kick us off with a question from an Environment alumni. He asked, how does the work of ECO contribute to the Pan-Canadian framework on clean growth and climate change?
So I'm a watchdog. I'm not a participant in the framework. But we have called strongly for putting a price on carbon for many years, and glad to see that we now have one. In that report, Facing Climate Change, that you saw the first slide, one of the things we looked at was the key design questions for how to do cap and trade right. And we think that our commentary and critique has helped the government improve its game. So for example, 2 years ago, the province said that they were going to use $1 billion of cap and trade proceeds to subsidize electricity rates. That, in my view, is clearly improper and contrary to the Act, because subsidizing electricity rates doesn't reduce emissions, and cap and trade money must be used to reduce emissions. So our report came out, and miraculously, the government decided that they wouldn't, after all, take $1 billion for the proceeds for electricity subsidies. So we can't make the government do things, but when we draw attention to issues, sometimes the government fixes them.
Sure, great. We did have a question come in on the board from Heather McPhail. She was asking how nuclear power can contribute to climate change. So are there greenhouse gas emissions, I think is what she's asking in relation to nuclear power.
So nuclear power is a major source of low emission electricity. So in Ontario, about 20% of our total energy comes from electricity, and it's the smallest and cleanest of our major energy sources. And one of the reasons we have low emission electricity is that 60% of our electricity comes from nuclear. So there are some emissions certainly in building a nuclear plant. And there are definitely some environmental issues associated with the uranium mining and with disposal of nuclear waste. But I've reached the point of thinking that climate change is such an enormous and fast-moving catastrophe that in comparison, nuclear waste is a comparatively small problem. I wish I had the luxury of worrying more about nuclear waste. Nuclear isn't, I think, a long-term solution. Certainly not the way we're building nuclear plants these days because of the waste problem. But for now, as we move through the renewable transition, nuclear is helping enormously. Countries like Germany, which have given up their nuclear power, have seen their GHG emissions skyrocket.
Sure, okay, thanks. And Heather actually clarified, I think she was also interested in knowing about, I guess, storage of nuclear waste. Is that something that ECO reviews in any way?
So her question is, aren't radioactive waste worse than CO2 emissions? No, in fact. I think it's really clear that climate change is much, much, much worse than radioactive waste, important though radioactive waste is. She's also got a question about aerosols in the atmosphere. I'm not exactly sure what the question is there.
We can come back to that one. We did have a question come through from Jonathan asking about the role of citizen science in monitoring climate change. Are there programs that people can contribute data to in that regard?
Absolutely. That's a very important role that citizens can play. One of the ones that I know of is Nature Watch, which has been collecting citizen observations of leaf out and ice breakup. And I think they have a worm watch, at least they used to have one for worms as well. Also, their groups like Ontario Nature do enormously important work in observing species, particularly reptiles and amphibians, which are very strongly affected by climate change. And they have citizen science programs that are just great. And I would encourage people to look for an opportunity to contribute.
Sure, and I do know we have some Ontario Nature people on the webinar, so if they want to post anything in the chat links, feel free.
Right.
Were you going to say something, Commissioner?
Well, just one other thing that people can do, I mentioned reducing your own footprint. One really easy thing for people to do is keep their organics out of garbage. We talked about that in our waste report that just came out a couple of weeks ago. Organics in landfills create methane. Well, they contaminate groundwater as well, but they create methane, which is an exceptionally potent greenhouse gas, about 100 times worse than carbon dioxide, which also helps create ground level ozone, which is a human health hazard, as well as itself a greenhouse gas. So the really easy thing, don't ever put food waste in the garbage. Put it in a green bin, compost it, feed it to an animal, but don't put it in the garbage.
Okay, that's a great one. We did also have a question from Julie asking about suggestions for decreasing aquatic pollution and changes as a result of climate.
Well, there's a lot of different kinds of aquatic pollution. The acidification of the oceans that I mentioned is an enormous challenge for anything that builds a skeleton, which is basically the whole basis of the food chain. So anything we can do to reduce our fossil fuel use reduces carbon dioxide that goes in the atmosphere. Another really major poison that we're putting into the oceans and lakes is mercury, and again from coal use. So anything that again reduces coal use is tremendously valuable in reducing mercury deposition in the oceans. And then there's plastics. Plastics are just a terrible scourge in the oceans. And so getting away from plastic whenever possible is, particularly plastic packaging, really good thing to do.
Okay. Heather had a question too about the use of aerosols in the atmosphere to increase sunlight refraction. Is that something you're familiar with?
Yes. So there's a number of people saying, all right, if it's too late to stop the kind of heat gain that we're experiencing by reducing emissions, should we put something up in the air that makes it harder for the sunlight to go through? And if you remember the chart of the 20th century average, that in the 1950s, world average temperature went down. And the main reason for that was that the air was so filthy that aerosols, sulfur aerosols, you remember smog, acid rain, they were very hard on human lungs, they were very hard on forests, they were very hard on wildlife, they were very hard on built assets, but it helped keep some of the sun out. So we could do that again, but the costs are enormous. There is some work being done saying, all right, what if we not so much aerosols, but fine dust particles? If we threw a whole batch of dust high up in the atmosphere to slow down the heat gain for a while we did other things, would that be a good idea? And there are some serious people looking at it. That one of the many, many challenges to it is that the distributional effects would be uneven. So some people would be winners and some people would be losers, and the losers might not like it. So it might, for example, change who gets water and when.
Okay, something to consider. In terms of other kind of mitigation techniques, there was a question about carbon sequestration, for example, in trees and other wood products. Is that a solution that might help in terms of reducing carbon?
I am enormously in favor of planting more trees. But it's less certain how much that will reduce GHGs, because the question then becomes, will the trees burn down? And we've already doubled the risk of forest fire. You've seen the enormous fires on the West Coast and in the US. And so it's important, but unless we can keep the trees from burning, it won't last. James Lovelock has promoted biochar, which is a way of basically making charcoal and burying that because it stays in the ground a long time. The French are pushing hard for using cover crops and so on to increase the organic carbon content of agricultural soil, and that has a lot of promise. But none of these things are really fast. However, I will say that increasing the carbon content of soil is an unmitigated good thing. It's good for the quality of what you grow in the soil. It's good for preventing erosion, which puts phosphorus and pesticides into our watercourses. It's good for making farmland more resilient to both floods and droughts. It's definitely a very good thing to do, and it will help somewhat with sequestration.
Excellent. And then we did have another question going back to oceans from Julie. Is there a way to, So is there a way to slow the issues that are facing the ocean right now in terms of acidification because of climate change?
Well, the best way is to reduce what we emit. I mean, the reaction between the ocean and the atmosphere where carbon dioxide dissolves into the ocean from the air, I don't know any way to stop that. It's basic physics. Although I will say, as the water warms, it will be able to hold less carbon dioxide, and so some of that will be belched back into the atmosphere. But the main thing is, yes, every ton of GHGs that we produce is bad. And the largest single determinant of how bad climate change will be and ocean acidification will be how many tons of GHGs we emit. And we in Canada have very, very big feet. We use a lot of fossil fuels. We create a lot of emissions directly and indirectly. And as some of the richest people in the world, we have taken more than our fair share and need to do our fair share.
Now, speaking to the point of some places like Canada and Ontario in particular having very large footprints to our population level, is climate change an issue that is related to population, or is it more of a footprint per individual? Because someone's wondering how a one-child policy would be an effective tool.
I mean, it's a fair point. You know, one of the suggestions of one of the metrics going around is, okay, what can people do that matters? Well, flying is a big deal, but the number of children we have in rich countries is a very big deal. Most of the analyses I've seen suggest it's not, climate change isn't driven by the large number of children in poor countries. It's driven by the consumption of basically the top 500 million people, which is mostly rich people in rich countries. So population does matter, but consumption is a bigger factor.
So arguably something like a one-child policy in a developed country could have a bigger impact depending on consumption rates.
It's certainly true that every child in a rich country has a bigger impact than a child in a poor country.
Okay. Yeah, I think we still have a few minutes, and there's a couple more questions coming in. Everyone's chatty, it's great. There's a question about, we've talked about what an individual can do, but are there actions that major companies and their stakeholders can take to decrease impacts?
Oh, absolutely. There's an enormous range of things that everyone can do at every level. And figuring out your footprint and reducing it 5% a year, that applies at every scale. That definitely applies to big companies as well as small ones. I do spend time talking with big companies as well as individuals, and they do have tremendous opportunities precisely because they have such big scale. Some of them are definitely doing things, and the challenge often is, again, how far ahead can they get than their customers? So if you want to see a major company producing lower waste products or lower GHG products or labeling their products or making things that last longer, you know, that's one of the big challenges we have, that even something like EcoStar, we measure the energy use in the operation of something, we don't measure its durability, which is in many cases a very large factor. So if you want better behavior from business, one thing to do is to tell them so and be clear and explicit. And the second thing is then to buy the stuff that they offer when it is better. They are looking hard to see, will consumers do it? So for example, I had a discussion with the president of a major company a couple of weeks ago about whether consumers would buy products, miniature products, highly concentrated, small packages of things. And what tends to happen is people see a large package and they see a small package for the same price and they think they're getting more if they get the big package. Well, what they're getting in the big package is a lot of water because it's a diluted product, which has then had to be transported around, and then a lot of waste that has to be created. So it's hard. I know it's hard to always be trying to figure out what to buy, but speaking up and then buying those things that are better will help.
Okay. So you can make change with your pocketbook, essentially.
Yes, but you have to speak up, right?
Yeah.
Buying things is important, but it's even more important to tell people why you're buying those things and tell
Okay.
Right?
Perfect.
And Canadians in particular tend to be very shy, and they think if they know something, then other people know it. And if they know something, other people have already spoken about it, and that tends not to be true.
Okay. Fair enough. I just had another question come in that I think is a good one. What countries currently are role models in slowing climate change? So are there any outstanding countries that have fantastic policies in place?
Well, there's quite a few that are doing really good things. Costa Rica is outstanding, looking for ways to have a lower greenhouse gas footprint and general climate footprint and to preserve their natural resources. The Nordic countries generally have been working hard at trying to adopt good policies and putting a price on carbon. They've got higher carbon prices than most other places. California has done quite a lot with their cap and trade system since they started putting a price on carbon in 2012. Their economy has grown faster than any other part of the US. Even Quebec has seen outsized growth in their economy since they started putting a price on carbon in 2015. Can't remember exactly what year they started. So yes, there are lots of examples. France has done a number of good things related to their hosting of COP23. So there are good examples all around the world. But the simplest thing to do is put a price on carbon. As I say, we've now started to do that. But that's a really important thing is if you favor this, you need to speak to your political representatives and tell them this. People who support stuff tend not to say anything. It's only the people against things that tend to speak up. And that warps politics.
No, that's a good point. I think we have time for maybe one or two more questions. So I saw one that kind of relates to the report you were doing on the forest fires and changes in forest ecosystems because of climate change.
Yes.
So there's several different forest types in Ontario and Canada. Are those forest zones affected differently by climate change in a notable way, or like I guess is fire common across all of them now, like, or is it more of an issue in the boreal in relation to climate change?
Yeah, no, it's a good question. One of the things I didn't get a chance to say is that climate change can be very local. I have a map which I didn't get a chance to show of how growing seasons are changing in Ontario. Now, on a world scale, Ontario is not that big, but there are places in Ontario where growing seasons are increasing by 10, 12, 13 days a decade, which is lightning speed if you're a tree. And there's places in Ontario where the growing season isn't increasing at all. So the actual impacts, they're affected by topography, they're affected by altitude, they're affected by proximity of bodies of water. Actual impacts can be quite local, and that's important in terms of protected areas, trying to figure out what areas to protect, to provide climate refugia, and paths for species to retreat north. But every part of Ontario is being affected by the increased unpredictability of precipitation and the increased variability of the weather. So Thunder Bay, and this isn't a forest story so much, but in Thunder Bay, the Minister of Transportation was telling me they used to be able to count on things freezing up and getting snowy in November and staying that way till April. And now what they have is they have freeze-thaw cycles through the winter. So they're now starting to get the kind of concrete spalling that we're used to in southern Ontario, but that their roads were never designed for. Same kind of things are happening to trees. So the increased variability, really tough on many species. And then again, we need to think harder about, well, what else can we do to make those forests healthy so they can withstand the invasive species, the fires, the droughts, the floods that are coming their way.
Okay. And I'm going to do one last question, and it's back to water again. Someone asked, we talked a lot about the oceans absorbing additional heat and increasing in temperature. Is the same thing happening to the Great Lakes, and are the effects similar?
Yes.
Okay. Are there any sort of resources on that?
Lake Superior, I think I remember, was one of the fastest heating large lakes in the world. It's very hard on species, cold water fish. You think about trout, for example, that need high oxygen water, which warming lakes have less and less chance of providing. And if the turnover comes later in the season, they may run out of oxygen before the turnover occurs. So that's a key kind of example. And one last question I see, shouldn't government make the data available to communities so they can differentiate their response? Absolutely yes. The government keeps promising me they're going to make an announcement on that. I keep waiting for it, but sometime soon we'll have an announcement on that.
Okay.
Thank you very much, everybody. I would encourage you to go to the website if you haven't, take a look at the report. If you can use hard copies of the report or the executive summaries for yourselves or for others in your communities, we'd be delighted to send them to you. So thank you so much for your attention, and thank you for taking climate change seriously.
And thanks so much for your time, Commissioner Saxe. We really appreciate it.
My pleasure.
All right. So thanks everyone for joining. I did notice one or two questions that we didn't get to answer. I just want to let you know that one in particular was about soil formation and climate change. And you can look at the What Lies Beneath Your Feet supplemental resource on our website. And it talks about how changing temperature and conditions are modifying soil formation, which answers that one question. So like I said, we'll be recording this and posting it. So again, thank you for your time. And if you have any comments or questions, you can reach me at forestontario.ca. My email is listed under the About Us section. Great. So thanks, everyone.